I'm Enda Lee. In this tutorial, I'll be showing you how to get started with MVC Web App development using the Play framework for Java. MVC stands for Model View Controller. It's a design pattern which divides the application into three distinct parts. The model represents data used in the application, the view is what users see and interact with, for example web pages and forms, and the controller handles requests and decides what logic to invoke. Each part can be changed without affecting the others. Here's an example. So first, the user makes a request for the home page via their browser. The application routes the request to the controller, and the controller loads the home page view and generates a response, which is then sent back to the browser for display. This tutorial is 4 parts. First, we'll look at how to install the Play framework and look at the guides available on the website before creating an application. In part 2, we'll run the application and examine the request-response lifecycle between the browser and the server, and to do that we'll use the browser developer tools. In part 3, we'll look at how the application is organised. We'll look at the directory structure of a new application and identify the locations of all the important files. We'll do that using a file manager and also with Visual Studio Code as a code editor. Part 4 will take an in-depth look at how the application works. We'll create a new page by adding a root, controller method and a view. You will see that separation of view and controller means that a web page can be modified without making changes to the Java code. Finally, we'll compare the application code with the HTML displayed in the browser. Web application frameworks such as Play make development easier by bringing together the various components required to build an application. Play also defines the application structure, which helps keep everything in the right place and easy to find. There are many alternative frameworks, but I won't be getting into comparisons here. Start by opening the playframework.com website. Here you will find details about its features as well as documentation, including installation instructions. The Getting Started guide describes how to install prerequisites, including the Java JDK. The guide can be found in the documentation section. The Play framework can be installed on Windows, Linux, Mac OS or any operating system supporting the Java JDK. See Installing Play under the Getting Started guide for details. Play requires Java 1.8 minimum. The Getting Started guide describes how you can check this and how you can also update if necessary. You'll also need to make sure that Java is added to the path in your operating system so that it's available from the terminal or command line. The SBT tool is used to build applications and run them. If SBT is installed, it also allows you to create an application directly from the command line. Next, we look at creating an application. There's a link at the bottom of the Getting Started installation guide, which will bring you to that page. There are a number of ways to create a new application. If you've installed the SBT tool, you can use that directly from the terminal to download the Play Java seed and create a new application on the fly. You can also use the Play example projects. If you click that link, it'll bring you to a list of projects in the download page. There's many pre-written examples here which may be useful. Make sure you use the Java version and you use the latest examples. Also, back in the the creating a new application page, you'll find the method that we're going to use, which is using the Play starter projects. This is the easiest way to get up and running. So if I click the link to download a starter project, it brings us to this page. So under Play Starter Projects, I'll find the Java starter example, which I can download as a zip file or view on GitHub, which is the option I'm going to look at. So if you click on that link, go to clone or download, I can copy the URL, and then I'm going to open up the location in my file manager where I store web applications. So open my terminal there and type in git clone and then paste in the URL. So when I do this, it will go and clone it from GitHub. Now out in my file manager, I could do all this from the terminal, but it's easier to do it this way. So I'm just going to rename that. It's a bit of a mouthful, Play Java Starter Example. So rename that to, doesn't matter what you call it. Obviously you will have a name for your project. I'm just going to call it Hello World. And then we can go into our folder and see the structure that has been created. So this is what's been downloaded from GitHub. If we look over here, we'll see the same structure and also the README file, which describes how to get started with this, how to access the running application. So this really is a starter example that explains everything in here. So have a read of this. We'll look in more detail of the structure of the application in the next section. So to get running, you need my terminal at this location. Easiest way to do it in this VM is to right click, open terminal here, and then I can type in sbt run. Okay, or just sbt actually. I want to show you this. Now, while that's working away in the background, it's going to build the application, get it started, and host it on the HTTP server. In the documentation, if you want to find out more about the SBT console, go back to the Getting Started guide and documentation and look at this section here, using the Play console. It will explain the various commands, how to get help, and explain some of the output that you may see while you're running. Now back to my terminal, and I see a lot of warnings here. It's going to these sites to download the various dependencies. Now what's happening here, I'm getting the warnings because I already have the latest version installed, and the project may be referring to a different version, but we can safely ignore these. Right, so this prompt here is telling me that I'm at the Play Java Starter example. Now you'll notice that I changed the name of the directory, but the project name comes from here. So this build.sbt configuration file here defines the version of the Play framework, SBT, and so on that I'm using, and also the name of the project. So if I want to change that, I'll need to go in here and change it, but I'm not going to worry about that for now. Also, I should point out that we're in the SBT application here. So if I type the usual bash commands like ls, I get an error. That's not going to work. I can only type in SBT commands, which again you'll find in the documentation in this section here. So the using SBT console under the Getting Started guide. So I'm going to type in run. That's going to again check for more dependencies. It's a repeat of what you saw earlier, more or less, but this time it's getting the application up and running, and you'll see listening on HTTP at this address. Now this address is IP version 6. It's the equivalent, that big long IP address here, IP version 6 IP address, is equivalent to IP version 4 localhost, or 127.0.0.1, which is what we're going to put into the browser in just a second. It's also running in port 9000, so that makes sure it's separate from any other web server that may be running. You'll see here as well that it's running the application and that auto reloading is enabled. This is a useful feature which we'll make use of later on. It means that we can change the code or change something in the application, and we don't have to manually recompile. The build tool will do that for us. So the server started, use enter to stop and go back to the console. So if I press enter, it now stops the server. Start it again, I type in run. So we'll have a look in the browser now. Don't worry about the double message here, I just didn't clear the screen. So I'm going to open up a new tab, keep that aside for a second. And as I said, I'm going to use localhost, so I can spell it right, localhost 9000. It's easier than the IP version 6 address, which isn't very user friendly. Now, when I type that in, if you look in this terminal, you'll see that it's compiling. So this is where auto reloading comes in. So it's looking at my application and checking for changes. If it's the first time, obviously it has to compile because it hasn't been compiled before. So it might take a little bit of time. It's showing me the various configuration settings, and now you can see my new application is ready. And this is just the welcome to play page, which we'll modify in the next section. But this shows that it's up and running. Now we'll take a closer look at how the application works, including the request response lifecycle in the web browser. We'll use the browser development tools to help see what's going on. Now it's important not to close the terminal window while the application is running. If you do that, then the application will stop. So I'm leaving that in the background. In the browser, I have the page loaded here, and I'm going to open up the developer tools. So the easiest way is to usually press F12, or you can go to one of the menus or right click, depending on your browser. But most browsers, F12 will start it up. We're going to go to the network section. When you open it up first, it will be empty, so you have to reload the page to populate this. And what the network tool will do is keep track of everything that's going on from the browser to the server and back again. So when I refresh the page, I'll see these requests here. So get / is the first one we'll see. And then we'll see all the other dependencies loading up in the background. So get main, hello.js, and a few other things here, which we can ignore for now. So when I click on the very first one, I see get /. That's actually the instruction issued by the browser to the web server. So when I type in localhost 9000, if I don't specify a particular page, the web browser will request the root directory, or whatever the default page is in the root directory. So that's where the / comes from. And we'll see that later on the server side, how it's actually handled. So the full request is here. You can see HTTP localhost 9000. It's using request method get, and then there's the resolved IP address. We also see that the server returned a status code of 200 OK, and you can have a look at the details of that further down. So there's the request header. I'm just going to minimize that one for the moment. Response. There's all the details sent by the client to the server, and then the response contains the results back from the server. The actual page is in the response tab here. This is the headers. There's cookies, which we haven't used. Other parameters we haven't used either. The response will show the actual page content, which gets sent back from the server. So that's looking at the request from the browser, goes to the server over here, which is listening, and then that sends back a response to the browser, which gets displayed. The application structure is described in great detail under the anatomy of the Play application section in the Getting Started guide, which you can find in the documentation. If you open up that page, it describes all the different sections of the application and what you should expect to find there. Now, this is a good start because it can be a bit daunting at first when you look at the structure in, say, the file manager. There's a lot going on there. There's a lot of different sections. So where do you start? If you wanted to modify your application, you'll need to figure out where to go to actually make those changes. Now, when you learn the structure, it's not actually that difficult, and it is quite sensible, but figuring out at first can be difficult. The main sections of the site that we're going to look at for now are the public section, conf, and app. Now, while you can do this in the File Explorer or Finder or File Manager, depending on your operating system, it's much easier to do it within a code editor or IDE. I'll be using Visual Studio Code, which is an open source cross-platform editor from Microsoft. Interestingly, it was voted the most popular development environment in the Stack Overflow 2018 survey. So you can get Visual Studio Code from code.visualstudio.com, and the instructions are there for your particular operating system. To open our project, we can do it in two ways. First of all, I have Hello World open here in my file manager. If I open up a terminal and type in code /. This works in the Linux environment. VS Code can also be started from the application menu in your OS desktop. So I'm going to go up here and open it from the link. Now, when you open up from here, you should always open the folder and not the individual files. It's always a good idea to edit our files in the context of the overall application so that everything's saved correctly. So when we open up, we'll see the structure here. Now, as I said, it can look a little bit daunting at first, but once you understand the main parts, then it's not so bad. First of all, we'll look at the public folder, and this contains static content. So if you want to put in style sheets, such as this one, or images, or JavaScript, things that don't change dynamically between runs of the application, that's where they go. Right now, main.css is full of CSS supporting the application is ready page that you see here. That's just a sample page. We'll probably get rid of most of that later on because it's not needed. The next most important folder is, well, actually it's probably even more important, is the conf folder. There's application.conf, which at the moment is all commented out because it's not in use. But this is where you go to configure things like application security. So that's an example there, the hosts that are allowed. We'll need to look at that later. Also database configuration. So if you want to connect to a database, you do it here. And other various configuration options for the application. Routes is another important file in the configurations section. So earlier on we looked at an example in the web browser where we're requesting the root directory of the website with a GET request, so GET /. So this is the request that comes into the application, and this is the method that actually handles it in the controller. So remember the model view controller. The controller is the part that handles incoming requests and decides what to do with them. Now you'll find the controller and views, for that matter, in the app folder. So that's up here. So we have our various controllers. We're going to be using this one here, the home controller, which you saw a second ago in the routes file. Also the views are in here. The main things for now are public, conf and app, which we're going to look at in more detail when we modify the application next. I'm starting with the application opened up in Visual Studio Code so that we can have a detailed look and make some changes in a while. We'll start by getting it running again and view the request response lifecycle or revisit that in the browser. So what happens from the initial browser request back to the application and then back to the browser again. And that will help us understand more what's actually going on within the application. So if I can start it from the view menu, I can use the integrated terminal. You can of course use an external terminal, but this is just handy if you're already in the VS Code environment. So this will bring me directly to my folder here, and I can type in sbt or just sbt run, and this will get the application up and running. Okay, so I'm just going to close that down and start it again from scratch. So we're loading the application here, and now the server is running. So open up my web browser, and straight from the start I'm going to open the developer tools. So press F12. This is just as a reminder to what we looked at before. We're in the network tab here, so we can have a look at what's going on from in between the browser and the server and back again. I'm going to type in up here localhost 9000. Now it's HTTP as opposed to HTTPS. You can configure it for a secure connection, but we haven't done that, so it's not going to work if we type in HTTPS. We get an error. So localhost 9000, and there's a request for GET /. That's what I wanted to see, and it's still loading. It's making the request. That's gone through now. You can see in the background it's compiling. So we have our request URL, the method, and the resource we're looking for, which is /. Now, as a reminder, the / indicates the root directory of the site. We don't know exactly what file we're looking for. We'll just let the web server deal with it and send back the default page for that particular directory. So you'll see in here we have a response, which is the page, just the code for the page we're seeing here. Starter page, welcome to play. Now in the application we'll have a look at the corresponding files. So when that request goes to the server, it goes via the HTTP server and into the application. And the first bit of the application that needs to do something is routing. So if we go into conf and open up routes, we'll see the routing for this application. And this really just contains a number of requests that can be entered in at the browser, and then their corresponding server-side handler or controller method. So remember, the controller is the part of the application that handles requests and sends out responses or results. So GET /, and that's again what the browser sent, is mapped or forwarded to controllers.homecontroller.index. So that's a particular method which we can find in the app folder under controllers, which is already opened up here. We'll just minimize the others for a moment. You can ignore these two controllers here, which are just default ones created with the new application, and go straight to home controller. So we have controllers, so it skips the app bit, but it's controllers.homecontroller and then .index, which is the method that's actually returning the result. You can see that there, it's a public method, index, which is returning a result, and this returns OK. Now going back to the browser, you will see in the header section, if you look at the response header, you will see somewhere here, oh yeah, it's up here, 200 OK. So it's returned OK back to the browser. It's also returned the result, which is the page that's being displayed in here. In our case, it's returning a view. So it's returning index.render and it's passing in a message there. We'll come to the views in a second, but for now, I'm just going to delete that index.render bit and we'll just pass it back directly. Your new application is ready. I'm going to leave an intentional error there. I'm not going to remove that particular bracket at the end. Save that file, and because it's using auto reloading, when I refresh this, it's working. Okay, well actually it isn't working, but it's working. It's showing me the error, and this is a useful way for debugging your application. In the browser it will show whatever's missing. In this case we're missing a semicolon at line 20. Okay, we actually have an extra bracket there which is causing it to report that error, but we can see where it is. And that will also be displayed in here. You see that the error message is displaying in here as well. So we can look at it in both the terminal and in the browser. So if I go back to here and just get rid of that extra bracket, save again and reload, this time it will show me your new application is ready. Literally just the text. So I'm returning that piece of text. It's not HTML, it's just the message. If we have a look at that in the browser tools, get / and the headers for this should show that it's so requesting that particular page, returning 200 OK like before, and the response is just that message there, nothing else. Okay, so I'm going to go back to here and undo that. Go back to our original view and we'll have a look at what the view actually is, what's actually being rendered. So this is taking index and rendering it and passing in this message as a parameter to the view. You'll find the view templates under the views folder of app. So in here you'll see index.scala.html. That's the page that gets loaded by the index controller method. So index.render causes this page to load up and display. It's a mixture of dynamic content as well as static HTML. The dynamic content is defined in a scripting language called Twirl, which you'll find in the documentation. So if you look in the documentation, you'll find a reference to the template engine. And down here, you'll see mention of the magic @ character. Every time you see an @ character, it refers to dynamic content that gets processed on the server side before sending to the browser. So you're not going to see any of these things here actually displayed in the browser HTML. Now the simplest example here is this comment. So comments start with @ asterisk and end with * @. The next thing we have is a parameter list. So this @message string bit here is used to accept a parameter from the controller. If you look in the controller, it calls index.render and you see a message here between the brackets. So it's sending that to the template and we need to accept it somewhere in the template. So this @message, this list of parameters, we could have more than one separated by a comma like that, but we only have one in this case. We're defining it as a message of type string, which obviously must match the value that we're sending. This is a string, so we need a string to store that value. I can add a little comment in here like this, which is, just going to say param list, or param list will do. So that's a very simple example. Down here we have other references, another comment, and then we have another @ which is calling this main template here. We're not going to use this for now. If you wanted to share a common template with all your pages in the site, this is a useful way of doing it. We'll come back and revisit this later on. For now, I just want to keep it simple. And finally, down here we have an @welcome, which is another page that we're loading up. This welcome page here is what you see when you load up this startup site for the very first time. So welcome to Play and information about the Play framework, how to find help and so on, and the general structure of the application. It's worthwhile reading this, but as we're not going to use it anymore, I'm just going to delete it for now. So in fact, we're going to delete all of this reference here right up to the message. And I'm going to just insert my own HTML in here and not use the template. So save that. If I reload it in the browser right now, it's not going to be very interesting. So go back to localhost 9000. It will recompile the page and it will just be empty. Okay, so there's nothing here. I've deleted everything from the page. You'll see that this content here, the @ stuff, just doesn't get displayed in the page at all. Even if I've used source, it's completely empty. So I've got lines 1 and 2 there, but they're blank. Let's zoom in, make sure you can see that. So there's an empty page. Okay, so I'm going to put some content in now. I'm going to use the Visual Studio Code shortcuts. If I type in HTML, it'll let me select the HTML5 Emmet abbreviation, which just fills out the content of the page for me. And we can put that directly in there below this content here. And I can put anything I want in here. So H1 and press enter will complete the tags for me. I can say the home page or something. It doesn't matter what I put in. Save that and refresh it in the browser. Now you'll notice we're modifying what's happening in the browser, what gets displayed without changing the controller at all. And that's possible. It's made possible by the separation of view and controller. You can edit them independently and it shouldn't have any effect on the other. Well, within reason. We'll see later on that if you send a variable from the controller, well, and you don't accept the parameter in the view, it's going to throw an error, but within reason you can edit them completely separate of each other. So if we want to make use of that, speaking of the message variable, if I want to show that in the page, down here in another H2, I'm going to put in @message. And remember, the @ symbol refers to dynamic content. So that's going to be interpreted at runtime and displayed. So refresh again just to see what the message actually says. So your new application is ready. And you'll see that's the message from here. I can change that message in the controller. So if I select the message that's sent to the index view and maybe just type in something like hello world instead, then reload the page, it should show my new message. Hello world. Okay. Now, just related to the @ symbol, if I go back to the view and I leave out the @ symbol there, the variable name, remember, is message. I can call it whatever I want, but if I don't include the @ symbol, it won't display the variable. It'll just show message. Likewise, if I want to display an email address or something containing an @ symbol, I have to be aware of that too. So if I just show you what happens, if I type in email@me.com or something like that, doesn't matter what it is, save it. Now that's going to be interpreted as dynamic content, which is a little bit of a problem. We'll see what happens. So I refresh the page. It tells me compilation error, value me, not found. So it's actually, the templating engine is expecting a variable named me. To display an email address, you actually need to override the variable or dynamic content by putting in a double @ and then the system will know that you mean to display the @ symbol and that me isn't a variable. So you can see that it ignores the first @ symbol and just displays the second one. Next, we're going to add some CSS to change the color of this text here. So back in the site, if you remember from earlier, the public part of the directory structure is where static content goes, including style sheets. There is an existing style sheet which we could use, but there's a lot of stuff in there already, and I don't want to confuse matters by adding to that. So I'm going to create a new style sheet. Right click on style sheets, the best place to put it, create a new file and call it style.css. And then we can create a couple of rules in there, one for H1. Color, we make it, doesn't matter what you make it, we make this one red. And H2 is going to be, let's say blue, color blue. If you want to add any more rules, feel free to do that. Save the file, and next thing we're going to insert it into our template. So back to index.scala.html. If you go to, actually I'm going to delete that one and do it from scratch. If we go to where we want to put in the style sheet, just type in link and go to link CSS, and then you can type in the name of your path, and you'll need the path as well as the file. So you might be tempted to do something like this. It's in the public folder, so if you type in /public /style sheets /style.css and save that, and let's see what happens. That would seem like the most logical way of doing it, but doesn't actually change anything. It didn't work because the application doesn't know about the public folder. There's no root defined to public. So to see what the root is actually defined to, we'll look in the roots file under conf. The very last line shows that we are mapping the static resources from the public folder to the assets URL path. So the physical location of public is actually mapped to the logical location of assets. And that's what the application is expecting to see when you want to access one of those resources, like a style sheet. So instead of public, if we put in assets and save that and then open up the page, we should see that it works. Now the root is actually found. The recommended approach to linking resources is to use reverse routing. You can find details about that in the documentation. And what this will do is use a special controller called the assets controller to check that the content exists and that the content is correct at compile time. It's especially useful for JavaScript for debugging purposes, but we can still use it for other content like images and CSS. So it's a good idea to get used to doing that. So we call it by calling it dynamically at roots.assets.versioned. And then as a parameter, we pass in the resource that we want, also in quotes. So that's going to be style sheets /main. I'm sorry, not main. We added our own style sheet called style.css. So make sure it's in quotes. That looks, oh, didn't spell it right. style, style.css. So I'll save that. It shouldn't actually affect the output, but as I said, it allows the application to do some checking at compile time. So it's now going to find that and load it up just as before. Finally, I'm going to add a new page to the site. So I'm going to add an about page, which we're going to load up like this. So /about is going to open up the about page. Right now it doesn't exist, so when I type in that address, there's no root found, so it generates this error that you see here. So our very first step will be to add a root in for about. Now it's going to be a get request, just like our previous one. So get, I'm going to tab across or space across, whatever it's using, and then type in the name of whatever it is I want the user to type in the browser. So I could type about us or whatever, it doesn't really matter. Over here, I'm going to put in the controller method. I'm just going to copy and paste that bit because it's going to be in the same file. So it's going to be controllers.homecontroller.about. Okay, so right now I have my root. So /about will call homecontroller.about. If I save that file and try it, this time we should see a different error. This time it's telling me value about is not a member of controllers.homecontroller. This is a very common error. If you forget to put in the controller method or you get the name wrong in your roots file, you will see something like this. So get used to dealing with this error. Read the message that you see if you do get something similar to this. It's telling me very clearly here what's wrong. Roots line 7, it's pointing to the line and it's showing me what it says. And up here it's telling me that the value is not a member of the home controller. And that's actually true because if I open up the home controller, I have an index, but I don't have anything for about. Now, if I take that existing method and we're simply just going to copy that, call about, and I'm going to, instead of index.render here, I'm just going to call about.render. I don't need this message here, so I'm just going to get rid of it. So about.render without the message, and save that file. We're going to try and run it again. This time around it should find the controller method, but this time it's telling me that cannot find symbol variable about. So I'm trying to return okay about.render, but about doesn't exist. So what I actually tried to do here was look up the views folder to try and find about.scala.html, because that's where I referred to here. It doesn't exist. So I'm going to just take a copy of that and paste it in again and just rename it as about.scala. Then just get rid of that one, about.scala.html, and change a few things in here. First of all, we don't have any parameters this time. If you look at home controller, I haven't sent a parameter, so I'll just leave it in to show you what happens. So Control Z that. Down here, I want to just change this to the About Us page, and the About Us page here as well, just so we know it's different. I'm going to leave this message thing in here as well, just to show you what happens when I have a variable in the page that doesn't have any corresponding value or parameter. So this time when I call about, I'm going to see a different error. It's useful to get used to these errors, right? You learn from your mistakes, obviously. This time, method render in class cannot be applied to given types. Some of these can be quite cryptic. So the reason is actual and formal argument lists differ in length. So if we have a look at what's actually going on there, in this first example with index, I'm sending one parameter and I'm receiving one parameter. So the argument lists are the same. They have one going out, one coming in. With the next one, with the about method, I'm not sending an argument. Okay, so about.render, there's nothing there, but about is expecting a parameter here. So if I just get rid of that, those two lists should exist, and get rid of it from down here as well, because it doesn't obviously exist, so it's not going to display anything. I now have our parameter lists are the same, so there's nothing going in and there's nothing expected here. Refresh, and we should see it's compiling in the background, this time the About Us page. Okay, so it's working. And I want to get the index page and get the home page, right? So I can manually navigate between them like that. In the next tutorial, I'll look at linking pages together and using the template and doing some more advanced stuff like that. But for now, that's it. This basic introduction shows you the main concepts of getting an application up and running, adding a page, making some changes to the site, and also getting familiar with the structure of the site and where to find everything you need. So that's it for now.